Cool. So I guess let's get started off. Hi, everyone. My name is Daniel Rosenwasser. I'm a program manager on the TypeScript team at Microsoft, and I'm here to tell you about TypeScript. Just by a quick show of hands, who here already uses TypeScript? It's a lot of you. OK, cool. For those of you who aren't familiar with TypeScript, we like to joke around that this pictures why the team exists. JavaScript has a lot of good parts, it's a great language, but unfortunately has a lot of pitfalls as well. And part of the idea of TypeScript is to help guide you to the pit of success instead. So the way that we do that is we took JavaScript as a language, and what we did was we added a static type system. These static types, the syntax allows us to analyze your program better so that we can look at declarations and where those declarations are used, so that we can know that if you ever refer to a property or mistype it or something like that, we can give you a little error message. So we can give you a little red squiggle, just the same way that you get when you're in Microsoft Word. Now, we go beyond just red squiggles, right? We can give you auto-completion, refactoring, go to definition, all that good stuff. And so if you're using an editor like Visual Studio or VS Code, you get all that for free. In fact, if you've been using these editors with JavaScript, all of that is actually supported by TypeScript's language support there. So that's TypeScript in a nutshell. It's JavaScript with types and tooling. And it's not just our tooling anymore. At this point, we're very community-oriented, and so TypeScript works with any JavaScript tool out there. So nowadays it works really well with ESLint, and we made sure that this was a decent experience. We've been putting resources into this. And if you prefer not to use the TypeScript compiler to remove your type syntax, and you want to get to remove your type syntax, you can use the Babel compiler instead, and it doesn't give you type checking. But if that's your preference, you can pick your tool. And if you're doing front-end development, the good news is every framework nowadays works really well with TypeScript. So either they're written in TypeScript or they support TypeScript right out of the box, which is always really awesome to see. So when we see how the community is responding to all of this, it's been really positive, right? In the last 2 years or so, we've seen twice as many people who would use TypeScript again in the State of JS survey. In GitHub's Octoverse survey of open source repositories, they found that TypeScript is the #7 most used language over time, which is nuts to me because this is ahead of languages like C and Ruby. And this is an empirical study. And in Stack Overflow's survey results, this sort of backed up as well. So they listed TypeScript as the 7th most used language among developers and the 3rd most loved, which warms my heart a little bit. But on top of all of that, NPM took an enterprise survey recently, and they found that 62% of developers they surveyed said that they were using TypeScript in some capacity. And so some people ask, is TypeScript going to be big in the next couple of years? And the news for them is it already sort of is, right? This is a major player in the JavaScript ecosystem, in the developer ecosystem in general. So, what's new? This is what you came for. And the bad news is that this is a 20-minute session, so I can't talk about all the great stuff. So my first lead is that we try to make everything extremely transparent, and you can always read up about this stuff if I don't cover it today. We make our public planning roadmap available. We make our iteration plans available. You can actually look at our release dates ahead of time. And so speaking of release dates ahead of time, TypeScript 3.7 literally just went out about an hour and a half ago. And so if you're not currently using it, go npm install this thing right now, or continue watching for the rest of the talk. But TypeScript 3.7 has some of the most exciting features that I've seen in a while. They're some of the longest standing user requests. And one of my favorite ones that we worked on is something called optional chaining. Now, optional chaining tries to solve a really common problem that we have in JavaScript. Do you ever end up with these really, really deep nested objects that have like properties on properties on properties, but in the middle, any one of them might be null or undefined. So you have to do this truthiness check at each point. You have to say, well, if object is there and object.prop is there, then try to get object.prop.nested. And it's just a pain. You have to repeat yourself over and over and over again. And so optional chaining does something where instead of having to do the check each time, you can write this new little question dot operator. If you're coming from a language like C#, I'm seeing applause from the front row, like light applause. If you use a language like C#, some people call this the Elvis operator because it kind of has like the two eyes and the hair. I know we have a resemblance, me and Elvis. But the idea here is this question dot is just like a plain dot when you're trying to get a property. But what it'll do instead is, before it actually tries to grab the property, it'll check if the thing on the left-hand side is null or undefined. And if it is, it'll say, stop everything that we're doing. Don't go any deeper into this property chain. So if object is undefined, then the variable value over there is going to be undefined. And similarly, if prop is undefined, the whole thing is going to be undefined too. And this is one of the most widely, longest standing issues that we've had on the issue tracker. It's actually issue number 16 on our issue tracker. And our issue tracker is up to issue number 34,000 and something right now. This was filed about 5 years ago. And the reason that we didn't do this for the longest time was because it was a feature that could potentially conflict with a future JavaScript proposal. And for the longest time, we were getting feedback from the community that was actually like the highest rated comment here, which was, please just implement the feature, right? We just want it already. So what we did instead was we did what we feel is the right thing, and instead of just implementing it ourselves, we got more engaged with the standards process. And so we went to TC39 and we started helping out with this feature, and then we started championing it. We actually became the champions of this proposal after a while, to the point where it is now at stage 3, which means it's a signal, hey, go try to implement this thing. And I'm happy to tell you all that I'm going to be trying to push this for stage 4 next month at the standards committee meeting so that it's part of the next version of JavaScript for every user in general. Now, that's all great, but I'd love to show you an example of this in action. Do you all see this? Okay. How's the text size here? Who can not see this? Okay, cool. So here you have the same sort of check that I was talking about. You have to check if session.user is present, and then if you can, you try to get session.user.name. It's actually kind of small up here. That's better. If I hover over this getDisplayName function, you can see that the inferred type is string or undefined, right? So we'll try to deal with that undefined in a second. But what we want to do is cut down on the cruft. So nowadays, if I write session.user, I can see that's an optional property, as you'd expect. But then once I try to dig deeper in, I get a completion for name. This actually was not provided in older versions of TypeScript because it was supposed to be a hint to you that you have null or undefined, and you need to find a way to deal with it. Now you have a way to deal with it. So when you accept the completion, we'll actually auto-insert the question dot for you. And so now you can dive in and say to uppercase. And so you'll end up with the string or undefined, just as you did before. You didn't have to repeat yourself at all. And now we want to deal with that undefined as well. So what I'll do is I'll write no user logged in. I'm a very good UX person. This is what I would put on a website. So we write no user logged in, and we hover over this thing, and now it only says it returns string. There's a minor problem with it, and it's kind of arguable. If I ended up with a user that had a name that was the empty string, like literally no characters in their username, this thing turns up to be falsy, and then we'll say no user logged in. Now, that's sort of like an artificial case. Like, you probably wouldn't end up with a username with no text in it, but this is the source of a lot of bugs in real-world code, things that can actually just crash systems for no reason. And so what we've done in recent versions of JavaScript is the little partner proposal to optional chaining, which is called nullish coalescing. And so the idea is, instead of using that double bar for or, what we'll use is this double question mark that checks if the left side is null or undefined, and if it is, it picks the right side as the default. And this way, you don't end up having to worry about things like falsy usernames and falsy ages. So like if you have an age which is 0, you might think that's an invalid value, but babies have an age of 0. So I mean, you want to handle these things appropriately. You want to actually get type-safe checks. So that's optional chaining. And I guess I shouldn't have jumped back in here. The next thing is declaration and allow.js. So I'll dive back into the sample. And if, as I mentioned before, TypeScript actually provides the editing support for JavaScript in editors like Visual Studio and VS Code as well. The way that it does that is through type analysis, but the way that it supports libraries that are not written in TypeScript is through something called declaration files. So if I jump to the definition of assert here, it jumps me to this DTS file, which tells me all the signatures of methods and functions that I might use, all the types that they expect, all the types that they return, things like that. These DTS files are handy for supporting your editing operations, but they're also really handy for generating files that don't need to be fully checked at project boundaries. So if I'm using something like project references, I only need to build against the DTS files. I don't have to do a full type check of the dependencies at all. So that's really handy, but unfortunately, while TypeScript allows you to generate DTS files from TypeScript files, it didn't allow you to do that from JavaScript files at all. Even though all the type information was actually there, right? So if I hover over this thing, it's using JSDoc to infer all of this information. It knows that the input is a uint8 array. It knows that width is a number, and it knows the shape of my exports as well. So in TypeScript 3.7, a new feature that we worked on was the ability to generate DTS files from JS files. And so what I'll write is tsc-p. I'll compile this project. And then in a sec, you should see that this DTS file was generated. And notice that it uses pure TypeScript syntax. It kept around the JS doc. So you still get information when you hover over it. You get the comment that the user provided. But everything uses TypeScript syntax and TypeScript export syntax as well, even though we were using CommonJS. And now I can actually import this thing from a TypeScript file. So I can say import import this from, how do I do paths? Something's not going right here. OK. And then I can say I want to import blur image, so I get a completion for that. And then when I want to blur image, I can actually get signature help and all that good stuff as well. And so what this means is, if you've got like a really, really small project that you don't want to write in TypeScript directly, or if you're not completely bought off by TypeScript, but you want to provide your users with a better editing experience and you want to provide TypeScript support, you can write a library in JSDoc annotated JavaScript and then just generate DTS files for all of your users. And this is extremely handy. So this enables a whole different class of users to start supporting TypeScript and really brings together the TypeScript and JavaScript communities. So another really awesome TypeScript feature in 3.7 is something called uncalled function checks. So here I've got a user type, and I have an erase all data function. And in order to erase all the data, I need to be an administrator. So I'll just dive into the user and check if it's an administrator, except that isAdministrator is a method, not a property, not a simple property of type Boolean. And so what I probably meant to do was actually call this thing. And so while we thought this would be a major break to start checking, what we started doing is, if you're in strict null checks mode, and you never end up using that isAdministrator function, then this is clearly a bug to us. And so we actually tried this out on a bunch of code bases, and it found a lot of really great checks. So now we'll actually give you an error and tell you that you probably meant to call the function. And this comes up a lot. Like if any of you have used Node, there's a really, really annoying function called stat. And stat gives you back an object that has an isDirectory method. And I swear, every single time I misuse this thing, I always forget to call isDirectory. And so now you will actually get an error, just as you would expect. But not just that, this actually caught bugs in a lot of existing code. Like, we actually found Visual Studio Code bugs because of this, where they were just failing to check for symbolic links and things like that, and so like it just never worked and no one noticed. It was kind of weird. So now, they were happy, we were happy. Hopefully you'll all be very happy too. Another thing I want to talk about, it's not 3.7 specific, but it's all about faster builds. Our users keep asking us for faster builds, and I don't understand why, because for me it's just a longer coffee break. But if you want faster builds, we've been trying to bring it to you for years now. So just to understand like some of the optimizations that we can do, it's good to know what the compilation cycle for a TypeScript project is. You start off with your project on disk, right? This is like a server-grade disk. I don't know why I couldn't find a better one. You start out with your files on disk. You run TSC, and that brings in all the files into memory and figures out what their dependencies are, and builds up what's called a program graph. Now, this program graph needs to go one by one and type check and compile each of these files. And then once it's done, it finds a way, it basically emits all of these files back to disk. Now, this has some overhead. When you have to initially start up the process, you need to, that's a couple hundred milliseconds. Then you need to bring in all the files. You need to calculate what everyone's dependencies are. It ends up being a bit laborious, right? It takes a bit. And so when you're in watch mode, that's a way of cutting out some of the time. You don't have to wait for the process start. And then we started adding a way of making it more incremental a while back. So we found a way to say, well, if your public API area of a file doesn't change, like your exports and your imports don't change, then the only things that actually need to be rebuilt are that file and its dependencies, but not any other files, right? And then similarly, if you've modified a file, but its API surface hasn't changed at all, you only need to build those files again, right? And so this was an optimization we were doing in watch mode, and it's been there for a long time, and so watch mode is pretty fast. But unfortunately, if you had a really big project, and you're starting up TSC for the first time in your day, this takes a while. Like, it takes a long time for certain really, really large code bases from what we've heard from customers. And so what we decided was we wanted to try to solve this problem for cold builds. We wanted to try to make cold builds incremental as well, and we added the incremental flag to do this. And this is so useful, which is why I'm telling you all, you should all turn this on in your code bases if you can, because there's, I think, no downside to this. Like, it's pretty much solid gains. The whole idea here is the first time that you run with incremental, it's going to figure out the state of the world when it compiled. It's going to figure out your compiler options, all that stuff, and then suck it into this one file at the bottom here called a tsBuildInfo file. This is just a build artifact. You don't have to check it into Git or anything like that. You can if you want, but the next time that you run with incremental, it's going to try to check for if this file exists. And what it'll do is it'll reuse all that information to try to cut down on the cost of calculating the entire program. And so for a code base like Visual Studio Code, it takes about just under 50 seconds to actually compile the whole thing, which is a ton of time. And if you're just making a single change that doesn't change the method signature of a function at all, it goes down to about 12 seconds. And this isn't watch mode. This isn't with the whole thing in memory. This is just a clean compile. So yes, it'll still be faster in watch mode, but when you first sit down with your cup of coffee in your day, you start compiling, this thing is a lifesaver. You don't have to just wait. Project references, I don't have time to talk about, but they're awesome. You should check them out if you have a non-complex code base. If you've got a client and a server, you're probably already going to benefit from this thing. And so I want to finish off with my favorite topic, which is UX, right? And I want to talk about the pyramids. But I don't want to talk about these pyramids. I want to talk about these pyramids. Unfortunately, these pyramids are not ancient history yet, right? And they've become kind of a joke in the TypeScript community, right? We have some pretty nasty error messages that people have kind of turned into a meme after a while, right? And it's a little bit funny, but it's actually something that I really think we need to fix, and the rest of the team agrees. So a while back, we started doing UX improvements. We started having these weekly meetings. We started having like actual plans per release to try to make things better. And the experience nowadays is leaps and bounds ahead of where it was. So as an example, here, you have this big old object literal, and instead of just highlighting the whole thing and diving in, we can pinpoint the exact place where things are going wrong and tell you a much simpler error message of what the incompatibility is. Another simple thing was when you try to assign one type to a union type, you need to be assignable to every part of the union type. So here, I'm trying to assign a string array to an array of number or a map of numbers. And TypeScript just says, oh, well, they're all incompatible, so I'll just pick one, and it doesn't matter. And that sucks. So what we do instead now is we actually take another step and try to figure out what the best type to report against is. And so in recent versions, we've done the work to try to match these things up with the appropriate types. And so we have a bunch of heuristics to say how many members overlap between the types, which ones have the right names, things like that. Other quality of life things, like if you're used to Python, C++, and C#, if you have a map, you might try to index into it with a string. But that doesn't mean the same thing in JavaScript. So we'll actually ask you if you meant to call the get method. If you have something that returns a number, but you were expecting a number, we'll ask if you forgot to call the expression. There's a bunch of small things that actually add up. And then there are actually just things that ruin your day when you get these. And so in some of these error messages, what we end up doing is we try to explain exactly each step of the way in the most verbose way you can imagine. Oh, well, these two types were incompatible. Well, why? Oh, because their properties A were incompatible. Because their properties B were incompatible. Because their properties C were incompatible. And I could have shortened that down, right, a lot. And so that's exactly what we do in TypeScript 3.7. We've found a way to just smush these things into one much more succinct error message and cut right to the chase. And so this is something that we're going to continue to improve on. We think this is extremely important because JavaScript is generally known as a pretty approachable language with a fairly low barrier to entry. And we want TypeScript to be in the same place, or at least around the same place. Check out TypeScript 3.7, check out our blog, check out our website if you're not already using the language. If you have any questions afterwards, come up to me. I'd be happy to answer them. And if you can, fill out an evaluation form. I'd love to hear your feedback. So thank you very much, and happy hacking.